Deductive reasoning is when you are proving something mathematically. And a proof is like a mathematical argument, showing that it's valid for all cases. So the conjectures kind of show a pattern that happens often, but a proof shows that it will always happen. And the way that we do this is we use let statements, and we prove something with a variable. So for instance, we sometimes let x equal a number. That's supposed to be an m. Okay, so if we let x equal a number, and we wanted to find the consecutive numbers, the next number would be x plus 1, then x plus 2. So if we were to write this on a number line, say, and this was our x, the next number would be x plus 1, because we're going x plus 1 more. The next number would be x plus 2, then x plus 3. And you can even go the other way. If we wanted 1 less, it would be x minus 1. X subtract 2. So these would be our numbers, consecutive numbers. And if we wanted to look at that as actual numbers, let's say x was 1. If we're going one step plus 1, 1 plus 1 is 2. 1 plus 1 is 2. 1 plus 2 is 3. 1 plus 3 is 4. And it goes the same way backwards. 1 minus 1 is 0. 1 minus 2 is negative 1. So as you can see, we can write consecutive numbers using variables. We can also let x equal an even number. And if we wanted to figure out what an odd number would be, we'd go x plus 1, because it's 1 after an even number. So if you think about it, if you start with an even number on a number line, we have x and x plus 1. If we start with 2 and we add 1 to 3, this will be an odd number. If you choose any even number, 2, 4, 6, 8, and you add 1 to it, you will get an odd number. So 2, 4, 6, 8. Plus 1 is 3, which is odd. Plus 1 is 5, which is odd. Plus 1 is 6, 7, just kidding, which is odd. You see the pattern? So anytime you take an even number and you add 1 to it, it will be an odd number. Another circumstance with odd numbers is if you have 2x plus 1. So because this 2 is an even, we know that anytime you multiply something by 2, it will make an even number. So let's try this. So if we do 2 times 2 plus 1, you get 4 plus 1, which is 5. 2 times 3 is 6, plus 1 is 7. So because we know that any time you multiply any number by 2, it will make an even number altogether, if you add 1 more to it, it will be odd. So this x over here could also be a 2x, and it works the same like that. So another way to write an odd number would be 2x plus 1. And we know that the words we use for operations, sum is addition, so adding, difference is subtraction, so minus something, and product is always multiplication, or a little star. So when we are using deductive reasoning, we're going to have 4 steps. The first is to find your let statements. Then you're going to write a sentence with your operations. Then you're going to simplify. Then you are going to check to see if your result matches your conjecture. So this is when you're going to deduce. We'll put. So let statements, operations, simplify, and deduce. So we want to prove the following conjecture. So the conjecture is, whenever you add 5 consecutive numbers, the sum is always 5 times the median. So first, let's just see if this conjecture works with an example. So let's go 1, 2, 3, 4, 5. So those are all consecutive numbers. And if you add 1 plus 2 plus 3 plus 4 plus 5, type that into your calculator or do it in your head, you should get 15. So based on the conjecture, the sum will be equal to 5 times the median. So in here, our median, which is our middle number, is 3. And 3 times 5 is 15. So this conjecture works with this example. Now we want to prove it for all examples. So we're going to let x equal our median. So if we have 5 consecutive numbers, 1, 2, 3, 4, 5, our median is exactly in the middle. So this is x. So our next consecutive number would be x plus 1, followed by x plus 2. And in the other direction, we have x minus 1 and x minus 2. So our 5 consecutive numbers are x minus 2, x minus 1, x plus 1, and x plus 2. Now we want to find the sum of these numbers. So we have x minus 2 plus x minus 1 plus x plus x plus 1 plus x plus 2. And we know that this is equal to our sum, big S. Now we're going to simplify. So what we're going to do is we're going to group our like terms. So we have an x plus an x plus an x plus an x and another x. So we have 5 x's. X plus x plus x plus x plus x. Now we're going to group our other like terms. So we have a negative 2. So plus negative 2, subtract 1, plus 1, plus 2. So we have negative 2, minus 1, plus 2, plus 1. Now we're going to simplify again. These x's turn into 5x. Negative 2 minus 1 is negative 3, plus 1 is negative 2, plus 2 is 0. So 5x plus 0 equals s. So this is what we're left with in the end. So our conjecture says that our sum will be equal to 5 times the median. And our median, we know, is x. So this is our median, and we found that 5 times x is our sum. So 5 times x is our sum. So 5x, which is what we did here. So this holds true for the conjecture, because that's exactly what we were looking for. So when you're done a proof, put a little square down at the bottom to show that you proved it. And that's it. So that shows that it will always work for 5 consecutive numbers, because x can be any number that you want. So for our next example, the difference between consecutive squares is odd. So we're going to do our let statement first. So let's let x equal our first number. And we want consecutive numbers, so x plus 1 is our next number. So our consecutive number. So the difference between consecutive squares. So because we're squaring the numbers, and we're finding the difference, we want to have the square of the number and the square of the consecutive number. And because it's difference, we're subtracting, so always put your second number first when you're subtracting, because we always want to subtract the bigger number from the smaller number. So x plus 1 squared minus x squared is equal to our difference. Now what we want to do is we want to simplify. So we're going to have to expand out these brackets. So x plus 1 times x plus 1. And when we have this, we need to distribute. So x times x is x squared. X plus 1 is x. And another x. And 1 times 1 is 1. And we're going to subtract x squared for this. Is our equal to the d, the difference. Now we're going to group our like terms. So we have an x squared minus x squared, so those are going to cancel each other out, plus x is 2x plus 1 is equal to d. So these cancel, and all we are left with is 2x plus 1. And now we want to check if our conjecture works. And because we know that 2x plus 1 is an odd number, this matches our conjecture. So we're done. So just put a square. So the product of two odd integers will be odd. So let's let x plus 1 equal our odd number. If we were looking at a number line, if this one is odd, then the next number would be x plus 2, which is even, and then the next number, which is odd, would be x plus 3. So x plus 3 is going to be our second odd number. I'll erase that. So our conjecture says that the product of two odd integers will be odd. And I wrote the question down. This is supposed to say sum, not product. My bad. Okay, so we're going to add together both numbers. So x plus 1, oh, it's supposed to say that the sum of two odd integers will be even. Man, I'm just writing this down wrong. Okay, so we're adding them together. So x plus 1 plus x plus 3 is equal to our sum. So now we're going to combine like terms. So we have 2x's plus 1 plus 3 is 4. And because x is an even number, we should have said that before, but we knew that from our number line, x is even, x plus 1 is odd. And because this number is also even, we know that the sum will be even. Because there's no way you could take an even number and add more even numbers and get an odd. So that's proven.